Hello learner, I am Dr. Poornima Tiwari, Assistant Professor of Mathematics, the Bhopal School of Social Sciences. In this video, you are going to learn about triple integrals. In previous video, I explained about single integral for the function of one variable, double integrals for the function of two variables and triple integrals for the function of three variables. To understand this concept, you must view previous videos to learn about double integrals. Let us start with triple integral. It is a way to integrate over three dimensions. Now suppose a continuous function of three variables, that is f of x, y, z is given and it is a function on the region R, where this x varies from P to Q, variable y varies from R to S and variable z varies from T to U, where these limits P, Q, R, S, T, U all are constants. Then triple integral of this function f of x, y, z with respect to v, that is dx, dy, dz is the integral for the limits p to q, then for the limits r to s, then for the limits t to u. For this function f of x, y, z and integration is with respect to x, with respect to y and with respect to z. You must note down, when the limits of integration are constants, order of integration does not matter. But when the limits are variable, you must integrate with very care. Now we will solve this integral for the limit 0 to 1, 1 to 2, 2 to 3, for this constant 1 with respect to x, y and z. First, we will integrate this with respect to z for the limits 2 to 3. So, to this integral we can write integration 0 to 1, 1 to 2, 2 to 3, 1 integration with respect to z, then dx, then dy. Now when we integrate this 1 with respect to z, we will get z and will apply the limits 2 to 3 and integration is with respect to x, then y. Now when we apply the limits, this will be 3 minus 2, that is again we will get 1. So in the next step, we will integrate that 1 first with respect to y and then with respect to x. Now when we integrate this 1, we will get y. So this integral as it is 0 to 1, we will get y. The limits of integration are 1 to 2 and to this dx. When we apply the limits, upper limit minus lower limit, that is 2 minus 1, we will again get 1. So here we will get integration 0 to 1, 1 dx. Now we integrate this 1 with respect to x, we will get x. The limits are 0 to 1. On solving, we will get 1 minus 0, that is 1. Thus, the value of this integral 0 to 1, 1 to 2, 2 to 3, 1 with respect to x, y, z is equal to 1, and that is our answer. Next we will integrate x square yz for the limits 1 to 2, 0 to 2, 0 to 1 with respect to z, y, x. So, first we have to do integration for this function for the limit 0 to 1 and with respect to x. To this integral we can write integral 1 to 2, integral 0 to 2. First we will integrate for the limit 0 to 1 to this function x square yz with respect to x, and then with respect to z, then with respect to y. Now, when we integrate this function with respect to x, this yz will deal like a constant and will do integration for this x square only. And integration of x square is x cube by 3. So, to this integral we will write 1 to 2, 0 to 2, x cube by 3. The limits will applied 0 to 1, this yz as it is, dz, dy. Now, when we apply the limit, first on applying upper limit we will get 1 by 3 and then applying this lower limit we will get 0. So, value of this term is 1 by 3. So, the next this integral is 1 by 3, 1 to 2, 0 to 2, yz, dz, dy. Now, in the next step, we will integrate this function for the limits 0 to 2 with respect to y. This integral is 1 by 3, limits 1 to 2. When we integrate this yz with respect to y, this z will deal like a constant and integration of y is y square by 2. Limits for this integration is from 0 to 2 and this dz as it is. Now, when we apply the limits, this 1 by 3 as it is, integral from 1 to 2, z as it is. When we apply upper limit, we will get 2 square by 2. When we apply lower limit, we will get 0, this dz as it is. On further solving, this term will give us 2. We can taken out this 2 outside this integral sign. So, we will get 2 by 3 integration 1 to 2 z dz. Now, when we integrate this z with respect to dz, this 2 by 3 as it is, integration is z square by 2 and the limits are 1 to 2. Now, this 2 by 3 as it is, when we apply upper limit, we will get 2 square by 2 minus 1 square by 2. When you solve, you will get 2 by 3 into 1 by 2 common from this bracket and 2 square minus 1 square, that is 4 minus 1. So, again you will get 3. This will cancel out and you will get 1. So, the value of this integral is 1 and that is our answer. Next, we will solve triple integral for the limit 0 to 1 for this exponential function of x plus y plus z with respect to x, y and z. To this integral, we can write 0 to 1, limit 0 to 1 and limit 0 to 1. Exponential of x plus y plus z. We can use the rule for theory of indices. A to the power m plus n is a to the power m into a to the power n. By applying this rule, we get this term e to the power x, e to the power y, e to the power z. And integration with respect to x, with respect to y, with respect to z. Now, to this integral, first we will integrate for this limit 0 to 1 and with respect to z. When we integrate with respect to z, this term e to the power x and e to the power y, both will deal like a constant. So, value of this integral is 0 to 1, 0 to 1, e to the power x, e to the power y. We will integrate e to the power z for the limit 0 to 1 with respect to z dx dy. Now, when we do integration, here we will get e to the power z, as integration of exponential function is again exponential function. We will apply the limits 0 to 1 and these two terms will as it is. Now, in the next step, we will apply upper limit. So, we will get exponential e and then just see, when we apply the limits 0 to 1 for this exponential, we will get e to the power 1 minus e to the power 0. Any number to the power 0 is 1. So, here we will get e minus 1. So, value of this term is e minus 1. So, now we write integral 0 to 1, 0 to 1 e minus 1 e to the power x, e to the power y dx dy. This e minus 1 is a constant. So, we will take out from the integral sign and now we will integrate with respect to y to this term e to the power y and for the limits 0 to 1. So, this will be 0 to 1 e to the power x as it is. We will do integration for e to the power y with respect to y for the limits 0 to 1. Now, again when we integrate this term, the integration will be e to the power y for the limits 0 to 1. When you solve, you will get e to the power 1 minus e to the power 0, that is e minus 1. So, this e minus 1 as it is, limit 0 to 1 e to the power x, value of this integral is e minus 1 and then dx. Now, again this e minus 1 is constant, we will take out from the integral sign. So, here we will get e minus 1 whole square and now the integration 0 to 1 e to the power x dx. When we integrate, integration of e to the power x is e to the power x and the limits are 0 to 1. When we again apply the limits, this will be e to the power 1 minus e to the power 0. So, this is e minus 1 square and this term will again be e minus 1. So, the value of this integral is e minus 1 cube. That is our answer. Next, we will integrate x plus y plus z with respect to x, y, z for these given limits. Now, to this integral, first we will integrate with respect to z for this limit 0 to 1. And when we integrate with respect to z, this x and y will deal like a constant. So, to this integral we can write integral 0 to 3, integral 0 to 2, integration for the limit 0 to 1 for the function x plus y plus z, first with respect to z dx dy. Now, when we integrate, we get the integration of x with respect to z will be xz, integration of y with respect to z is yz, and integration of z with respect to z is z square by 2, and the limits are 0 to 1 dx dy. Now, note that we will apply the limits only for z, as x and y are constants when we integrate with respect to z. So, we will get integral 0 to 3, integral 0 to 2. In place of z, we will write 1, so we will get x, here we will get y, here we will get 1 by 2. When we apply lower limit, so this term would be 0, this term would be 0 and this term also 0, as we substitute z equal to 0. Next, we will integrate with respect to y for the limits 0 to 2. So, this integral will be integration 0 to 3, then 0 to 2 of the function x plus y plus 1 by 2 with respect to y, then with respect to x. Now, when we integrate this function with respect to y, this x will deal like a constant, and the value of this integral is 0 to 3. Integration of x with respect to y is xy. Integration of y with respect to y is y square by 2, and integration of 1 by 2 with respect to y is y by 2. And then the limits 0 to 2 and then integration with respect to x. Now, we will substitute upper limit, that is y equal to 2. So, here we will get 2x plus 2 square by 2 plus 2 by 2. When we substitute lower limit, that is y equal to 0. So, all these three terms will be 0. On further solving, you will get integral 0 to 3, 2x, this term would be 2, here you will get 2 and from this point you will get 1. So, 2 plus 1 is 3 and integration is with respect to x. Now, when we integrate 2x with respect to x, 2 as it is, x square by 2, the limits are 0 to 3, plus 3x, the limits are 0 to 3. When we solve it, this 2 as it is, we will substitute x equal to 3, so we will get 3 square, this 2 as it is, and for the lower limit we will substitute 0, so we will get 0. Likewise, here 3, when we substitute upper limit x equal to 3, we get 3, and when we substitute lower limit x equal to 0, we get 0. So, the value of this term is 9 plus 9, which is 18. So, the value of this integral is 18, and that's our answer. You may solve some more example for better understanding of this topic. In next video, we will solve triple integral with the variable limits. Thank you so much.